Okay, for those of you that are watching the video, we have just sucked on M&Ms, and the outer candy shell dissolved first, and the inner chocolate shell dissolved next before the whole thing was gone. Dissolving we have equated to derivatives, D and D. When we look at number 1, there are 2 parts to this M&M. There is the outer candy shell and the inner chocolate. The outer function and the inner function. What is the outer function? Kind of the bigger piece of what's happening here. Yeah, it's something to the 4th. We're going to call it U. They often call it U. So we're going to put U to the 4th. That's our outer candy shell. And we need to dissolve it to get to the middle part. So we need to perform the derivative of U to the 4th, which is 4u cubed. Questions so far? Yes? So the outer candy shell, the outer function is that we're taking this whole piece and we're taking it to the 4th. That's the outer function. The derivative, we use the power rule, multiply by 4 and lower that exponent by 1. So we have 4u cubed. All right? The chocolate, the inner part, the inner function. What is the inner function over here? Right, 5x squared minus 4x plus 3. And then in order for the entire M&M to go away, we have to dissolve the inner part, the chocolate part. So we're going to perform the derivative of the inside function. Good, 10x minus 4. The answer for finding the derivative of a function within a function, the composition of functions, bless you, is we find the derivative of the outer function, multiply it by the derivative of the inner function. So the outer function's derivative was the second column, 4u cubed. The derivative of the inner part was 10x minus 4. Now the problem is they didn't give us u to begin with. So we need to replace that with what u actually is. And u was this inside function. So let's change this to 4 times u, which is actually 5x squared minus 4x plus 3. That whole thing is cubed times 10x minus 4. We could kind of multiply all that out and try to simplify it down. It may or may not make it any more simple or any smaller. We're just going to leave it like that for right now. Questions on how we did any of those boxes? Okay, let's move on. We have tangent of 3x squared, the quantity. Outer candy shell, the outer function is what? What's the bigger function here? The tangent. So tangent of u. Now we need to dissolve that candy shell. We need to perform the derivative on the outer function. What's the derivative of tangent of u? Secant squared u. All right, the inner function. What was the inner function? 3x squared. That's the function that's inside the bigger function. The derivative of the inner function is 6x. The answer is going to be the derivative of the outer shell, the outer function, times the derivative of the inner function. So I'm going to start to write secant squared u, but instead of u, what should we probably put? What is u? 3x squared. And we're supposed to multiply by 6x. Now if I write out here times 6x, what's the problem with that? If I write it out here off to the right. Yeah, you might think that it's secant of the whole thing. So that 6x probably ought to be up front. Any questions with how I got any of that? All right, third one. The outer shell, the outer function, what's happening? Yeah, you guys kind of already moved ahead of me, and that's fine. We have the square root of u, which you guys already said was u to the 1/2. Derivative of that would be 1/2 times u to the negative 1/2. The inner piece, the chocolate is what?
3x cubed.
Good. X cubed plus 2 is our inner function. The derivative would be 3x squared. And we've got 1/2. Instead of u to the negative 1/2, I'm going to go ahead and replace the u with what it is. It's that inner function of x cubed plus 2, and that's to the negative 1/2, according to that column, times 3x squared. Now, is that as simple as we can write that? No, it's really not, and we don't really have room on this worksheet, but I'm going to draw an arrow and pretend like we do. So for number 3, on the top, because this whole piece right here is going to move to the bottom, right? So on the top, all I have is 3x squared. Does everybody see that? You have 1 times 3x squared on the top. On the bottom, I have 2 times this whole guy to the negative 1/2. Yep, I'm sorry. Like that? Sorry. Which is really, if it's to the 1/2, it's a square root. They gave us a radical, so we have to give a radical back. And that's your answer. Kind of in simplified form. Questions on 3? Everybody okay? All right, you guys try number 4, and I'm going to start writing it as well. Let's see if we can make them match up. So our big piece, the outer function, was the cosine of something, so cosine of u. The derivative of cosine of u is negative sine u. The inner function was 6x, and the derivative of 6x is 6. I'm going to take negative sine of u times 6. I can't put that 6 at the end because it's going to look like I'm taking the sine of all of that, so I put it in the front. Also notice when I put it in the front, I didn't say 6 and then negative sine 6x, because it would look like 6 minus. So you have to kind of write it sort of, you know, math grammatically correct. Questions? Do me a favor and skip down to 11. What are you going to do with that one? What's the bigger function, the outer function? The outer function is division. Couldn't you also, though, just go ahead and rewrite this as x minus 1 to the negative 1? That might help some of you guys. You can do it the other way, but for some of you, you're going to prefer it this way. 17, the last one. Take a look at that. You guys have any thoughts or ahas or confusion? Confusion? This one's a little trickier. Yes, ma'am? It's a great question. You can approach this several ways. This one, if you wanted to do the product rule, you could, but you don't have to. Cosine of 3. I don't even see a variable. Isn't that just a number? Probably some crazy decimal. So this problem is really no different than me saying y equals 4x squared. It's just a number times x squared. So do you even need composition of functions, or can you just pull out the power rule and be done with it? You can just do power rule. Because this guy right here is just a number. So if that's just a number, then we could take, just like we did here, 2 times 4 would be 8, x to the first, right? So 2 times cosine of 3 times x to the now positive 1. Sorry. So now you just have to sort of write that in the correct order, which would be 2x cosine of 3. If you had done the product rule, you would still get this answer. So this one's a little harder to see, kind of your larger function and your smaller function. Your larger function would be u squared, but u is just x. So this one's a little trickier, but that is the answer. I'm going to have you and your whoever's around you kind of work together to kind of finish this whole sheet out. When you finish, all you have to do today is page 137, 8 to 20, even. If you can simplify in the major stuff, please do that.
Can you go back to the?
Yes, sir. It's on the board if you guys need it. That one, Nick?
Yeah, the very bottom.
Yep.